Hi, I'm Thomas. Welcome back to Pilot's Workshop. A table saw sled is the most handy add-on you can have for your table saw. It only does one thing, but it does it well, which is to allow you to make perfect cuts at a 90-degree angle and to do that safely and repeatedly. Its construction is very simple. Most measurements of a sled are completely unimportant and mostly depend on your saw, as I will show on my machine. The only important thing is to make sure that the fence is perpendicular in both ways. So let's begin. For the base I used 21mm coated birch plywood that has one grippy and one slippery side. I take the grippy side up. I cut it to be roughly as wide as the table saw surface and about 40 centimeters long, which is around 5 centimeters longer than my previous table saw sled, which served me well for a couple of years. The sled runs along one of the T-slots in the table surface, which my saw has 3 of. One of those would be enough to guide the sled precisely and without play. The strip should be made from a material that is both very durable and softer than the material of the saw table. So I use hardwood. Another great choice would be plastic. After I planed it to the right thickness, at which it glides freely in the slot without having any play, I cut it to the right height and fixed it to the base. The exact position is not crucial here, as long as it is pretty much perpendicular to the edge of the board and roughly where you want it to be. However, it is very important that it remains straight when you fix it to the base. I first put in a screw on each end. And after that, put additional screws while pressing the strip against the straight edge. The next step is to make sure that the sled moves freely along the rail. This might not be the case in the beginning, because it is almost impossible to mount the guiding strip without any distortion. So I fiddled the sled into the rail as well as I could, and then turned it around to see where it rubbed. The next step is to scrape those marks off and repeat the process until the sled runs smoothly and without play along the entire saw. You could use a scraper, or like me, a chisel that is held like a scraper. Especially when your table saw surface is made from aluminium like mine, it will be quite easy to see black marks in the areas where it got too tight. If this isn't the case for you, you could rub a graphite pen along the rail in the table that could then rub off onto the strip. For both the fence and the front support piece, I used some 24mm thick laminated hardwood, which would give me a solid support for screws to hold in. This part has to be most sturdy, because a sled like this will receive a lot of rough handling, which should not end up compromising its accuracy. The small support plate mostly has to be there. It does help, however, when it is as small as possible to allow for some oddly shaped workpieces. I shaped the fence to be a bit more comfortable. This shape also emphasizes the area around the saw blade and makes it more obvious where not to put the hands when cutting. Mounting the fence really is the only crucial step in the entire project. Here it is important to work as precisely as possible. At first it gets mounted temporarily with only 2 screws. I am using machine screws and threaded inserts for this step because it allows a small degree of adjustability that I will need in the next step. You could use wood screws for this, but this way is a bit more comfy, as I will show in a minute. I drill one through hole to be a snug fit to act as a hinge, and the other one a bit oversized in order to have some play. The front bottom edge of the fence receives a small relief cut to avoid small bits of sawdust or chips to back up against it and mess up the cut accuracy. Once the fence is in place, I measure its accuracy with a 5-cut method. I found this procedure in a video by William Ng. I will put the link to his video explaining it in full detail in the description below and in the end screen after this video. In this method, you take a piece of flat stock and square it up with your sled, always rotating the freshly cut side towards the fence and making the next cut. After 4 cuts, the piece would be squared up all around. Now a 5th cut is made, taking off a thin slice. With a perfect sled, this slice would have 2 perfectly parallel sides. Because we rotated the square after each cut, we amplified the fence's mistake by 4, and now we can measure it in the varying thickness of this slice. First we measure it at the end, pointing away from the fence, which is A. Then at the end towards the fence, which is B. The formula for the error to be adjusted is A minus B divided by 4 times the length of the slice times the distance between the pivot point and the position at which you want to make the adjustment. The pivot point is the first screw that I planned to act as a hinge with a tightly fitting through hole. The adjustment point is the right outer corner of the fence. The exact length of my slice was 198 millimeters. The distance between pivot and adjustment point is 680 millimeters in my case. The resulting error is around 1.3 millimeters in my case. Now we know how much to adjust. The question is, in what way? If the result of our small calculation was a negative value, it would have to be adjusted in a clockwise direction. But because the result is a positive number, the fence has to be adjusted in a counterclockwise direction. I use a small wedge that I marked at the required thickness to give me my error value. A feeler gauge would be the even better way to do this, but I didn't have one handy in this moment. I then clamp a block in front of my adjustment point, aka the corner of my fence. As my fence has to be corrected counterclockwise, I put the wedge in between the block and the fence before the adjustment, and clamp the block down. Then I can loosen both of my initial screws holding the fence and push it snug against the block. Now both screws can be retightened carefully. In case you're using wood screws for those two, you only keep the pivot point screw and put the second screw into a new position. Another test cut reveals that the fence is now perfectly square with a difference of A to B of only 1/10 of a millimeter. Now the fence can be secured permanently with a couple of wood screws. The small support plate can be fastened with any method. It helps to keep the base plate aligned, since we cut it in half. I again chose machine screws with threaded inserts to fix it to the base. One detail that I noticed while making the fence is that it would have been better to screw the support piece in place before I made the first cut into the baseboard, as it got very wonky during the adjustment with only the first 2 screws. So if you want to make your own sled, you should keep that in mind. The last step is to cut all the way through the fence and the table saw sled is finished. So if you have a table saw, I can absolutely recommend you making one. There is no faster, more precise and safer way of making the basic perpendicular cut on a table saw than with a custom table saw sled. This is Pilot's Workshop. Thank you for watching.